Everyone, welcome to this video. Now if you remember, till the last video we learned how to balance the imbalanced data, and for that we learned top 5 techniques, out of which the undersampling, oversampling, SMOTE, k-fold were 4, and the last one which we covered was the ensemble technique, which we had covered in the last video, which was ensemble technique. Now what we are going to understand in this particular video is how to save the model which we had created in all the previous videos. Okay, in the previous video what we were doing is we balanced the data and then we trained the model and we did the prediction. So whatever models that we had created, we are going to save that, and we will save that in a way so that after saving that, if you want, you can share that with your friends, with your colleagues, with your client, and they can simply just put their unseen data into that and they can get the prediction. It is going to be that simple. Now after this, what we are going to do is we will also do the automation of all those steps which we took to clean the data. While we were doing the balancing of imbalanced data, we took some steps which were needed to clean the data. We are going to automate that, and we will automate that and we will put that in a module in a way so that next time when you require it, you can simply do import that module and you can just directly use that function to clean your data. You don't need to take the individual steps. It's going to be that simple. Now after that, once that automation part is once that data cleaning part is automated, we are also going to automate the SMOTE balancing technique, right? Because we found that balancing was very effective, so we will be using this balancing technique further to train if we have to train further models, then we can use directly SMOTE balancing in the similar nature of data. Then further, if we want to do the prediction, right, once all this automation is done, then what we are going to do is we are going to put unseen data, bring the unseen data, clean that using our automated data preparation function or module, then use the saved model to do the prediction. Once that prediction is done, we are going to concatenate with the input data and then put that into the Power BI and then do the further analysis. All right, so without further delay, let me take you directly to the Jupyter notebook and let me help you understand how we can start with it. So here we are back in the Jupyter notebook. First we are going to say, first what we gonna do is I'm going to save the models which I want to use further. So first one is ensemble technique, right? So this one I'm going to first save. So to save that, this is the module which you require, import pickle. If you don't have it, then you can just do the pip install pickle and that will be available in your system. Okay, so after that I'm going to write this step with open, and here you need to provide a file name. So I'm going to say this was ensemble model, right? Ensemble model dot pkl is the extension, and after that here I need to write a method. So that is wb is write binary. I'm going to define it as file, and then over here I'm going to say pickle dot dump is the method which we need to use right over here. And what we exactly want to dump, this model which we had created over here. You see over here we had created and we did the prediction. So this is the model which we are going to dump, and here I'm just going to write file. This is done. Now if you want to check where is this stored, so this is stored in your working directory. So to check that, you require this OS module, and into that OS get current working directory, CWD. Let's see. So this is my current working directory. Let me just try to open this current working directory over here. Into this I'll just put this one here. Here is the one which I have already. Now you see over here ensemble model pkl is saved. Same way we are going to save other models. So for example, k-fold cross validation, I'm not going to save this because I'm not willing to use this further. It was giving me the F1 score of 77 only, right? So I will just put it on hold. I will not use this as of now. I will use this one where I trained a logistic regression model using I trained the logistic model on SMOTE balanced data balanced with SMOTE, right? So here I have already reused the logistic regression which was imported previously, but here I'm going to create another instance. I will say SMOTE logistic, and here I will just create the instance of logistic regression. So remember, this you cannot do unless you have this thing imported. You see over here, I have this thing imported, sklearn, linear model and logistic regression. So once you have that, then only you can do this. So now I'm back over here. This instance is created. After this, I will train train this model only. And after that, what else I need to correct? This one is done. Let me run this. Then prediction. Oops, there seemed to be some error. Okay, I didn't do the fitting of this model directly. I'm using this, isn't it? Okay, I need to do the fit of this model also. So what I'll do is I'll just write this dot fit into this. I'm going to write xtrain. Let me first run this entire cell so that xtrain will not be confused. Okay, and over here xtrain is created. The same xtrain I will be using over here, and I will use y train as well. All right, now this is done, and after that I'll do the prediction, then run this. This is here, and let's then run this. So this is 91. Okay, now I'm just going to save this model. Now what is this model? SMOTE logistic, right? Again I will use it because I have already imported pickle one, so I don't need to import that again and then again. I'm going to say with open, and here I'm going to say SMOTE. I'm going to keep the same name, SMOTE logistic dot pkl, and here I'm going to say wp as file, and over here I would say pickle dot dump, and inside that I'm going to keep the same name. I think I'll keep the same name. Okay, and the next thing is file. All right, I'm keeping the name same. If you want, you can have a different name. All right, so this is done. So we are done with the first step. We are done with saving both of the model. If you see over here, ensemble model and the other one, ensemble model and SMOTE logistic, both are saved over here. Next step which we are going to undertake is I'll do the automation for cleaning and the SMOTE steps, right? So here I'm going to say automate fraud detection data prep. All right, this is what I'm going. Okay, I might get the duplicacy on this. Fraud detection model data prep. Okay, model data prep. Let me say this, fraud detection model data prep. All right, this is done. Now let's do the preparation of this automation. Automation of this entire process. So first of all, this was our whole workbook, right? So out of this, what all that we require to bring. So if you are starting with any model development, right, any cleaning or etc., these are the basic libraries which you would require anyway, right? So I'm going to put this also over here. All right, next thing which I need is, let's say I'm done with importing the data, right? I will not automate the import process. Whenever I need to create the model or maybe do the prediction, then I'll do the import myself, and rest of the things I'll do using this one. Okay, so that's why I'm not going to put this step into it. Now the next thing which I will put inside that is this step where I'm deleting these two columns from my data data set. Okay, then what else? Then I'm creating the dummies. That step I will put inside my automation. Then I'm doing the concatenation of my data. That step I'm going to put inside it. And after that, I'm splitting that into independent and dependent, right? This is what. Now I need to do this def data prep automation, and inside that, what all I require is input df. I just need to put the input data inside this. Rest everything will be done automatically. So remember, you cannot use this method on any kind of data. You can use this method on only on that data which has the same structure. When I say same structure, that means the data look like this. When you import that, that should necessarily have all these columns, right? If you have all these columns, then only you can apply this data cleaning steps. So now you might be, if you're thinking, then what is the use of this? The use of this, if you're working in an organization and if you are creating the model development process, you are expected to have a process where, I mean, you're supposed to have a process where you will be getting the data in the same standard format. If yes, then you are going to be using this again and again. You will be able to use this again and again. If you are going to get the data in different format every time, there is no use. Every time you would require to do the data cleaning and bring it into separately and bring into this format. Okay, so this is created, this is done. Next thing which I'm going to do is I will automate this SMOTE balancing, right? So let me see where that SMOTE balancing steps are. Here are the steps, right? So first of all, let me import this if that is not imported at all. IMB learn oversampling import SMOTE. Okay, this is done. In case if you're going to use this, and if you think that IMB learn is not available, make sure that you first install this. Otherwise this automation will not work for you. Okay, if you get any confusion, do let me know into the comment section. I will definitely try to help you out on how to install that. Now this is done. In the here I did the separate splitting again, but in my case over here, once my data cleaning is done, over there independent and dependent part is already done. Over here I missed one part. Here I also need to do the return statement. I need to write the return statement. Return independent, this part, sorry, this comma dependent. This thing I would require to do the return. Now once I get this independent and dependent, I can directly put that into this SMOTE analysis over here. You see over here I can directly put that. So that's why I will not utilize this step. I will directly jump to this one now. Okay, this step is done over here. Next thing, I mean, this requires SMOTE require a separate trend test split. So I will do the trend test split separately for this SMOTE one. Okay, and this again I'm going to do. I really need to do this? I don't think, because I have already trained this model, so I would not require this. In case if I need to use this mode, I will just do the cleaning and I'll do the trend test split, and after that I'll directly utilize this mode logistic, because that is something which I have already trained, right? And now over here what I'll do is I'll say return these values, these all 4 values. Now this is steps. You see how simple is this? I'm just doing the copy paste from this step where we had already performed this sort of cleaning, right? So def, and here I'm going to say SMOTE balancing, and inside this, what exactly that we need to put? We need to put features and target. Let's say features and targets. After this, we would require to do some bit of correction. Over here you see I'm below oversampling. Wherever I have independent, I'm going to say let's just put this independent and dependent are going to be features and targets. Okay, now this is done. Features and targets are further splitted into this part. Same way here we defined input TF, and over here we are using the TF, so that will throw an error, right? So let me correct this. Okay, where is this new TF coming into the picture? Processed TF, new TF dot prep. New TF is here, right? This input TF is done, right? This looks okay. This looks okay. Okay, this is pretty much good. We are done with this. Now once you are done with this, next step which you should be performing is to save this one, right? So what I need to do is, see, currently this is a Jupyter notebook file. This is saved as Jupyter notebook file. What you need to do is you need to save this as .py file. Then only it will start working as a module. Otherwise it will not work as a module. Okay, so for that what I'll do is that you can do go in file, download, and from here you need to make sure that you download with this python.py. You download this. Once this is downloaded, you need to go in the download folder. Okay, let it complete. Show in folder, and from here it is important that we copy it and put that into the working directory. Okay, so here you see fraud detection model prep, model data preparation. Okay, so I'm going to take this and I'm going to go in this one. This is my model, this is my working directory. This is done. Here we got this. Here is what we got. Okay, model this is the code which we had saved, and this is the module. Don't get confused with model and module, right? So this is module. Now once you if you want to import that, then it will be very simple. You are done with this, and this is the next step is going to be super fantastic. How? So I'm going to open a new workbook further. Let me open a new workbook. While this is opening, let me show you the another data set which I will be using to do the prediction. So if you see in this one, here you see to test the model, I have a data set which has approximately 5,000 records, and that data I'm going to use for the prediction purpose. And for the prediction purpose I will be using this data. Once this is done, right, then what I'll do is whatever prediction comes out of that, I will put that over here, right? I'll put that over here, concatenate that, and then I will take it into the Power BI for the further analysis. So you see into this you have 4,500 records, and out of 4,500, how many fraud transactions that you have? Out of this you have only 500 for fraud transactions, right? So this is the data which we will be using in our prediction work using the automation part. Now this is done. After this, what we are going to do is I'm going to say import the model, the module which we had just automated, that was named with this one, right? Fraud detection model data prep, right? This is it. So this is exactly what you need to say. Import this as, I can say, as data prep. That is done. So it is importing it. Now this is imported. If you want to see what all are the functions that we have stored into it, then let's just say that data prep, and we need to call this one dir. So into this, if you see, we have label encoder, these all are the things. We have classification report, we have confusion metrics, we have data prep automation. You remember this data prep automation function which we had created, that is available into that. Then SMOTE balancing, this one SMOTE balancing which we created, that is available into that, right? SMOTE balancing is there, trend test split is there, so everything is available into it. Now let's just start. So the first thing which I will do, so if you would see into that, you have PD also. PD means pandas, yes. So into this module you have pandas, numpy, everything, so you don't need to use that separately. So let me just say input df equals to this module, and out of that I'm going to use pd, and out of that I'm going to use read excel, right? And then let me just go back over here, this one I will do copy as path, come back over here, and let's just put it. Don't forget to put r, because if you don't put this you would require to change this slashes in the from backslash to right slash. Okay, now this is doing the import. Done. Now let's just try to check this out. Input df dot head. Bravo. So we got the data into it. Now let's just check the shape of the data. We got 4500 records. Super. Now you see how simple, I mean, this proves that our module is working pretty well, right? Because you see this was the module, and inside that we have this pandas, and out of the pandas we are using this function directly to read the Excel file. So this proves that our module is working pretty well. Now let's just see if our data preparation, data cleaning part is also working pretty well. Okay, so if you see data preparation module is this one. So what we need to do is first use this module, okay, over here, and out of that we need to see which one that we require to use for data preparation, data prep automation, right? And inside this you need to just supply the data, input df. So if you would say, if you remember, so if you run this, if you do this data cleaning, what is the output it will be giving? It will be giving you input and dependent, sorry, independent and dependent, right? So accordingly you require to create two more variables in which you will be storing these two outputs, right? So for that I'm going to create one is called features, and then the other one I'm going to say target, right? Once that is done, then let's just check what is it that we got in features dot head. Bravo, we have this, right? And let me just check the shape. We got 12, and see, into this one we should not have the is fraud, right? We should not have that target column available. We don't have that, right? So is fraud is dropped, other unnecessary things are dropped, and this was the payment type. Payment type is converted into this true false boolean values, right? There was one column which in original data we had one column which is called type. All right, so now that we are done with cleaning the data, the next part which comes is doing the prediction. So for that prediction, you remember we had two models saved in our folder, in our working folder. Where is that working folder? Let's just find it out. Okay, let me just find out the working folder. I don't have that. This one. This is the one where we had our working which is our working folder, and you see these are the two models which we can try to use. So first one I'm going to try using this one, ensemble model.pkl, this one. So how to make sure that we can use it pretty well. Okay, so for that next thing which we can do is pickle was not available in our automation part, so we would require to import that again, right? Import pickle, and here I'm going to say with open inside this model, comma, this time I'm writing rb means read binary as file, and then here I'm going to say loaded, or I can directly say this ensemble model equals to pickle dot load, and inside this I can simply say file. That is imported. Now comes the time, examination time, whether what is going to happen, right? Let's just say features, done. Oops, it looks like object is not callable. It says ensemble model. This is not callable. What is the issue? Let me just see. Let me find it out. What's the issue? That object is not callable. Why is that object not callable? That we need to figure out. Alright, it is not callable because I am simply saying model, right? So I need to tell it what exactly that I'm looking for, right? So I'm looking for prediction. So let me just do this. So here is what we got. We got the prediction. Let me store this into it. Prediction. Let me write a variable prediction equals to this. And now our prediction is created. Let's just see the length of the prediction which we have done. 4500 predictions are available. Next thing, let's just check the classification report. Okay, so you remember classification report we had we have available in which module? In this data prep module, right? So I'm going to say data prep module dot classification report, and into this, so you remember for classification report you need to provide two things. One is prediction, the other one is truth. So truth I have available here you see features and target we had splitted. So here I did this just for the testing purpose. In real life, when you are going to use your model, so you would not have the target available, right? You can directly utilize the features, so you don't need to do this classification report and all those things. You can directly go ahead and use this prediction wherever you want, right? Now after this, what I'm going to do is data prep dot classification. Into this, the truth is target and the prediction is prediction, right? And let's just see the thing. Let me make it look pretty. Print, and after this you see over here we got 95% of accuracy. This is wonderful, right? Now the next one, I'm also going to do the same prediction using the other model. The another model which we had was named, what was that named for? This one, correct? SMOTE logistic pickle. Let's just see SMOTE logistic pickle. How is that going to work? So you see, we are not again developing a model or training the model. Already the model which was already created, we are just directly using that. So every time whoever wants to use your model, they would require to do this load, and once that is loaded, after that they can simply go ahead and use that. So SMOTE logistic dot predict, and inside this I'm going to put my features again, features, right? And let me say SMOTE prediction, SMOTE log prediction. All right, and let me just print this. Oh, we got this. It looks pretty similar, right? So now let's we got the prediction from this model also. Now let me prepare the classification report again over here, and I'm just going to change this one. You see, so our previous one, ensemble one, is of course working much better, because you see this is giving us only 71% of the F1 score for this class, for minor class, and this one is giving us 95%, right? The other one, so anyway, I'll take both of these two predictions, right? SMOTE log prediction. The other thing, you remember this one is a logistic regression model, right? So logistic regression also provides you the probability functionality, right? So let me just show you that. Here I'm going to say probability, okay? And after this, over here, let me just say prob dot predict probability, okay? And predict probability, let's just see what comes out of it. This would have the probability predicted. So out of this, you see it is this column is the prediction, probability prediction for wherever it is not fraud, negative class, and this is for positive class, means wherever the data says it's a fraud, right? So we require only this one, because that is what we are trying to predict, okay? So for that, what you can do is you can just do this thing, okay, comma 1. Let's just see what it does. Bravo, right? and let me just store it into this. Let me call it data. Done. All right, so we got three things, right? This one, then we got the prediction, SMOTE logic prediction, and then we have this ensemble prediction also. These three things we need to concatenate with our feature data, then only we will be able to use that in our Power BI. Okay, so that's what I'm going to do. Let me just try to zip them all together. I can directly do this. What we say, final data. Let me say final data equals to data prep dot pd. All right, pd dot data frame, and inside that, what I would do is I would use zip. Okay, and in the zip concatenation, let me create zip this all together. Okay, this one comma this one, log prediction, probability data, and there was one more which was just this prediction. Okay, I'm going to put this also, and then after that over here I would say columns, and into the column I'm going to put the list prediction. Here I would say ensemble prediction, then this two SMOTE, let me call it SMOTE prediction, and then SMOTE probability. All right, let's just see what happens. Dot head looks pretty well. Now the next step is creating the final data, final outcome. Let me say final outcome. I know the video is turning out to be a little longer, but you see this is going to be the interesting one. This is something which is providing you the end solution. Okay, so don't worry about that. Then again, this is the module which we have. Out of that I'm going to use the PD, and then over here I'm going to use concatenate function, and I will concatenate it with features comma final data, right? And over here I would say axis equals to 1. We need to concatenate side by side, right? Whatever outcome that we have got, we need to put it just next to the final features which we had already. Dot head. And what I'm thinking is, I think I should use target also into the same one, right? I will put the target also, which is my original data, right? So let me put target as well. Target, and here I would say is fraud. That was the original data. Okay, let me do that, and then over here let me do this. Bravo, we got it. So this is the probability, this is SMOTE prediction, ensemble prediction, and this is reality. This is the truth. Now next thing which I'm going to do is I will just export this into Excel, and inside this I'm going to put the location where I want to export it. I will be exporting it in this location. Let me do this, data for analysis, and don't forget to put R over here, and don't forget to put the extension XLSX. Now let's just run this. Well, this is done. Next thing which we're gonna see is, please bear with me, over here, data for analysis. We got this data for analysis. Once this comes, we'll just do okay. So this is something which is not needed if you don't want that to be exported. So what you can do is, over here you can always write index equals to false, right? That will not produce that data. This is back over here. Now let's just see how does this looks like. So this is my truth. Let's see, whatever the true fraud was, whatever in reality we had the fraud 400, sorry 500 records we had, which were fraudulent transactions, right? Now out of that, ensemble 1 has predicted correctly how many? 499. Ensemble predicted 499 correctly, right? And SMOTE 1, SMOTE had predicted 452, right? With SMOTE logistic, we had got 452. So you don't worry, you don't think that this is something which is SMOTE which is reducing the accuracy. No, this is the logistic regression, and into this one, for ensemble we had used random forest, right? The latest random forest name was, let me tell you the name, this balanced random forest, the balanced random forest which we had used. Now let's see, for this genuine class, means wherever the transactions were non-fraudulent, how many of them are correctly predicted by ensemble. So there is one which is incorrect. No, there are quite a few. Out of 400, 49 were non-fraud, but our ensemble technique said that this is a fraud, and our logistic said 31 out of that, it said that it was the fraud. Now how many were truly predicted? So truly predicted was 3951. Means you see, out of 500, sorry, out of 4000 approximately, yeah, out of 4000, 3951 were correctly predicted. So it is quite good model, right? Rather I would say column n. Column n was the prediction. So this is quite a good prediction which we will further take into the Power BI, and we'll do the further analysis. We will see, we will focus on this probability. This is probability. What is the probability of this particular transaction being a fraud, right? That's what it says. So for example, if you take one from here, is fraud, out of the is fraud, so for this one it says that it is 99%, probability is 99% that this is going to be a fraudulent transaction. So if you will see, for all of them the probability would be more than 50% over here. If you would see, this is kind of non-readable, right? So that's why it is becoming like this. But yeah, this is how it is. So let's try to analyze this into the Power BI further. So I think the video has been quite long, and it would turn out to be lengthy if I continue Power BI development in the same one. So what I'll do is I'll pause over here and I'll cover the analysis in Power BI in next video. So stay tuned and just check out this analysis into the Power BI. That is going to help you a lot. Okay, thank you very much for watching this video. Give a thumbs up if you like it, and share it with your friends. Subscribe to the channel. Thanks once again. In case of any doubt, put that into the comment section. I'll definitely try to help you out. Thanks once again. Wish you very good luck.